Welcome to Let's Get to the Marks. Going to go through this question from the AS Chemistry 2024 paper 1 for AQA. And it's question 1, it's on halides. So question 1, a student does a series of reactions with aqueous solutions of some potassium halides, PQ and R, of equal concentration. Each solution contains a different halide ion. That's chloride, bromide, or iodide. The student adds 3 drops of bromine water to 3 drops of each aqueous solution of potassium halide. The student also adds 3 drops of bromine water to just 3 drops of normal water. And I guess that's proving that bromine water is orange. We've got the results here of the observation when the 3 drops of bromine water are added. Now it's asking us, can we identify the ion present in Q? Give the ionic equation for the reaction that occurs when bromine water is added to Q, and this is 2 marks. So we've got this brown solution has been formed here with Q. So I'm going to write an equation out for that. Obviously, which halide forms a brown solution? You should know this off by heart. That's going to be iodine that forms a brown solution. So I'm going to do the little equation. Bromine water, which has the symbol AQ, it's aqueous with potassium iodide, which would also be aqueous. Coming together, bromine is more reactive than iodine. So it's going to push out those iodide ions so that they form iodine, and the bromine's going to form potassium bromide. So we've got a displacement reaction going on, and that's the brown colour, is the iodine solution that's formed. So what is the halide ion in Q? Make sure you say iodide ions or you put I minus. Don't put iodine, because iodine is not a halide, it's a halogen. So slight difference there. Make sure you don't put iodine. That'd be incorrect. Okay, don't get your halogens mixed up with your halides. Halides are the ions of the halogens. Okay, now we're going to write the ionic equation. So if you look here, bromine goes from a 0 oxidation state to -1, and iodide ions go from -1 to 0. So whereas potassium ions stay at +1 on both sides of the equation. And that means my potassium ions are known as spectator ions. They don't get involved in the ionic equation, so we don't put them in the ionic equation. A spectator ion is anything that doesn't change its oxidation state on either side of the equation, or doesn't change its physical state, i.e. it's remained aqueous on both sides. So if you change one of those, your physical state or your oxidation state, then you're not a spectator ion, and we include you in the ionic equation. So getting rid of potassium, let's write this out. So we've got bromine plus I minus to balance. We're going to need 2 I minus, forms 2 Br minus plus I2. So that's nicely balanced. There's our ionic equation, and that will get you 2 marks. So moving on to the next part of the question, which is going to be 1.2. We are asked, explain in terms of oxidizing ability why the observations from these reactions do not allow the student to identify the halide ion present in P and the halide ion present in R. We'll look at the table. Halide ion in P went orange with the bromine water. The halide ion in R went orange with the bromine water. Now we know that one of them is chloride ions, one is bromide ions. Why does that not let us know? Well, because the chloride ions are not displaced by the bromine. Essentially, they can't be oxidized by the bromine, and we know that the bromide ions in potassium bromide also cannot be oxidized by the bromine. It's not a strong enough oxidizing agent to oxidize the chlorine or chloride ions or the bromide ions, essentially. And that's your answer. And that's why we can't tell which one is chloride ions and which one is potassium bromide, purely because they both have given the same result. They both turned out orange. So you can see from this equation above in orange that the bromine added to potassium chloride, there's no reaction. It's still, you're left with bromine and potassium chloride. And if you added bromine to potassium bromide, there'd be no reaction. You'd still end up with potassium bromide and bromine, so you'd still have an orange color. Right, let's move on to the next question. 1.3, the last part. The student does a second experiment to determine the halide ion in each of P and R, the two that ended up orange, so we can't tell them apart. The student adds a few drops of aqueous silver nitrate solution to 2 centimeter cubed of potassium halide. We've got a precipitate form. Now, you'd actually get sort of a white precipitate with the chloride ions and a cream precipitate with the bromide ions, but that alone is normally not good enough to work out what they are. What you need to do is add dilute ammonia solution. If you add dilute ammonia solution, the precipitate that contains chloride ions, the white precipitate, that is going to dissolve, whereas a dilute ammonia solution will not dissolve a bromide precipitate. However, if you were in a situation where you wanted to work out is it bromide or iodide, well, the bromide precipitate will dissolve in concentrated ammonia solution, whereas the iodide precipitate, which is normally yellow, so you can normally tell the difference because it's yellow visually, but the iodide precipitate will not dissolve in concentrated ammonia. So that's the way you can tell the difference between the bromide and iodide. But here we're just interested in how you can tell the difference between chloride and bromide. So we're using dilute ammonia. And that's the end of the question.
You're still here? It's over.